Hello everyone, welcome to Docker course. So we are going to talk about Docker today. We will talk about what is Docker, why Docker, and what is the importance of Docker in DevOps world. My name is Raman. So we are going to discuss why you need to learn Docker. Also, before moving ahead about the Docker, let's first talk about our OdinSchool. OdinSchool is a technology upskilling platform. We help you to continuously acquire the new skills. So stay skilled, stay ahead. My name is Raman. I'm a DevOps specialist with over 16 years of experience. I'm expertise in DevOps tools like Git, Maven, Docker, Kubernetes, and many more. I'm also comfortable with the programming languages like Python, Java, .NET also, which is a Microsoft, which is not an open source, but yes, some part you can say it's an open source. But I'm very much comfortable with .NET also, web platform, MVC framework, microservices. I'm equally good in cloud computing. I'm very much comfortable with AWS and Azure. That's all about me. So let's talk about today's agenda. At the end of this lecture, you will be able to understand what is the architecture of Docker. You will be having a good knowledge of Docker images and Docker containers. We will also talk about Docker registry as well. Okay, so let us understand Docker first. If you are totally new to the Docker world, let's compare it with the virtualization or virtual machine. In virtual machine, what happens that whenever you want to deploy an application, you first have the host machine. On top of the host machine, you install a guest operating system. The guest operating system could be Windows and could be Linux, right? So on the top of this guest operating system, you are installing your binaries. Binaries like your Java, your Python, .NET, etc. So that is the way which we are working as of today. So let me just go quickly to my whiteboard and we need to understand the difference between these two. So let us first talk about the virtual machines. So when we are talking about virtual machines, we have the host operating system. Okay, and this host operating system is talking to the hardware, right? It is talking to the hardware. So host operating system is having a kernel, and kernel of an operating system is the core of the operating system. Means any activity which is happening in an operating system is through kernel only. Whether it's a system calls, whether you are typing something and it is appearing on the output screen, it is because of kernel. So every task which you perform, that is through kernel only. So kernel is the one which is basically does everything for the operating system. Without kernel, you cannot imagine an operating system. Okay, on top of this, we have the hypervisor. Okay, so I will talk about the hypervisor in a bit. But on top of that, we are having our guest operating system. Okay, so it could be if you have multiple virtual machines, then multiple guest operating systems you are having. Okay, so this operating system is communicating to the host operating system through Hyper-V. Okay, so you can say Hyper-V is the medium by which Guest operating system is communicating to the host operating system, because when we are talking about the virtual machine, it is ultimately use the resources from the host operating system. Okay. Now on top of these host operating system, you have your binaries. What I mean by binaries means, say an example, if you want to run a Java application, you need to install JDK, JRE, right? If you are installing .NET kind of application, you need to install .NET framework. Same way here on the other operating system, you are basically installing the binaries of respective application. Okay, on top of that, your applications are running. So this is overall uh, how the virtual machine it works, right? So this is your hardware. On top of hardware, you are having your host operating system. To communicate between the virtual machines operating system and the host operating system, we are using Hyper-V. And on top of your guest operating system, virtual machines, uh, on virtual machine basically, you are having your binaries installed, and top of binaries your applications are running. I hope most of you are very much familiar with this virtual machine. When you when you prepare a particular virtual machine, you need say an example. I'm taking an example of say CentOS operating system. You need uh, 1 GB RAM minimum. This is minimum, okay? And you need 10 GB or 8 GB space. You need some other configuration which is related to virtual machine. So each guest operating system is is in the isolation. They are not going to interfere with the other operating system by default until unless we set up some networking or we set up other communication media. So this is how, and even though if you are running a simple application hello world, you need the complete operating system. Okay, it is not like that. If you need to run a very simple basic application of a of a of any software, then you can reduce the operating system configuration. You at least you need this one. Okay, which is fine, because prior to virtual machine, the data centers or our applications were running on the physical operating system. Now on one physical system, we have multiple virtual machines. Can we go with the better solution? VMs, when there was VMs, these were good, but now there is some alternates. One of the alternate is Vagrant, which is also creates the virtual machines, and it's very popular in the DevOps world. If you are going to create the virtual machines, you can provision your applications by using Vagrant. But this topic we are not going to discuss as of now. We are going to discuss other solution, which is Docker. Docker is a containerization technology. Okay, so Docker is a containerization technology. We will discuss what is containerization and how it is different from the virtual machines. So if we go back and compare with the virtual machines, so we have the host operating system, and this host operating system is having a kernel. Okay, this host operating system is communicating to the hardware. This is going to talk to the hardware, right? Because of this kernel. On top of that, we have Docker engine. Okay. On top of that, we are having a Docker engine. So what is this Docker engine? This Docker engine is basically a medium by which the binaries or libraries, we say, which is running as a container. And on top of that, we are running our applications. So this is a medium by which these binaries or libraries or containers can communicate to the host machine. Okay. So now let us compare this with this. Let's compare it with uh, virtual machine. How it is different from the virtual machine. So let me take this color. Okay. So virtual machines. So here you can see we need the entire operating system. So when you start your operating system in the virtual machine world, it takes full time to load the entire operating system, whereas in the Docker it is mounted. In Docker, your container image is mounted, whereas here it is loaded. That is why when you are starting your virtual machine, it takes time. Whereas if you see, means I will show you it today, that when you are going to start your container, it will be immediately start up. Does not matter whether you are running a uh, Ubuntu, CentOS, or any other container, and it will be immediately get started because it is mounted. Okay. Now this Docker engine, so this you can say runtime also, this plays a very important role. The reason is the images which we are using to run a container is these images are called Docker images. Okay, so these images which is running is called containers, and these images are called Docker images. The importance of this Docker images is that it is lightweight. It is lightweight. What is the meaning of lightweight? Here, when I was saying that this virtual machine is having 1 GB of memory it needs, 10 GB of hard disk space it needs. But if you see the size, and if you see the size of the images, ISO images, definitely it crossed 4 GB or 5 GB. But here it is hardly 100 MB, 200 MB, and if it is any sophisticated Docker image which has a lot of features, maybe it reaches to 500 MB. Okay, but as compared to 400 MB and 500 MB, you are just okay. So even though you are having the custom images, but these custom images depends upon you, means which software you are going to install in your image. Okay, that's a separate topic. But if we take the default images, so these default images are 100 MB, 200 MB, 500 MB, not more than that. Now you might be surprising. So this virtual machine is 5 GB. This is 500 MB. This is or not 500 MB, it's 100 MB. Why that much difference? Why Docker images are so lightweight? If I am running um, two virtual machine on a system, I need some space, right? Which is definitely if I run say an example 3 virtual machines on a system, now I can run almost 7 to 8 or maybe 10 containers. Okay, I can run 10 Docker containers. So this looks very, it looks very powerful means, but why that much difference? Why Docker images are so lightweight? The reason is Docker images comes without comes without. So I'm just emphasizing on without. So Docker images comes without kernel, whereas whereas in the virtual machine there is a separate kernel for each operating system. So if you have two operating system running as a virtual machines, so these two guest operating system has its own kernel. But in the case of Docker, the images are without kernel. If it is without kernel, then you might be thinking that if it is without kernel, how can it run? How can it communicate with the hardware? How can it communicate with the applications? Because kernel is the core of the operating system, and if there is no kernel, we cannot imagine an operating system. And you are saying that Docker is without kernel. And that is true because Docker images uses the kernel of host operating system. Okay, so my Ubuntu image, so say an example, I have one Ubuntu image without kernel. So this is my Docker image. When it runs, it uses the kernel of host operating system. That is why it is lightweight. Ultimately, these all are processes. These all are means if we talk about with respect to Linux operating system or any operating system, these are at last these are the processes only, and these processes are running in an isolation mode. These processes are running in an isolation mode means there is a separate process ID for my Docker service. So Docker is running as a service. For Docker, there is a separate process ID, and when we create the containers inside the Docker service, so these all are the child processes for that. Okay, so there is a separate C group get created. C group is basically used for you know grouping the on the basis of the CPU and memory, whereas the namespaces, so there are different namespaces get created which isolates the process of isolates the process of the Docker from the rest of the processes which is running in an operating system. I hope now you understand and you are having some basic idea about the Docker. Even though if you are not, if you don't understand it, don't worry. We will see practically, then it will be more clear to you. All right. So now let us deep dive to the Docker. Deep dive to Docker means let us talk about its architecture. Let's first understand this definition. Docker uses client server architecture. So Docker is built on client server architecture. So you know plenty of examples of client server technologies like your database server. You have one database server and you are connecting from your system, and basically you are using a database client software. So similar way, Docker uses the client server architecture. The client talks to the Docker daemon. So what is daemon? Daemon is a background process, and or in short, we say Docker daemon is a service. Okay, so here the Docker daemon means Docker service. Okay, which does the heavy lifting of building, running, distributing Docker containers. So what this daemon does. So daemon is everything. So ultimately the task is to be executed by the Docker daemon, which is running on the Docker server machine. Okay, so you can install Docker and Docker server and Docker client version on the same system, and that is what we are going to do. But means if you want to separate out, means you want to create one server and a client sends a message to the server, that also you can do it. But ultimately the task which you are sending to the Docker to perform, it is to be done by the daemon. So daemon is the Docker everything. Means ultimately daemon is creating the container, removing the container, or whatever the task you are running in the Docker world is to be maintained or created by the Docker daemon. So daemon is a background process, and or we can call it Docker service. Let us understand this Docker engine. So as I mentioned, Docker engine is basically the it is the uh, it is the software basically which is the communication medium between the host machine and your Docker libraries or application or containers. Okay, so this diagram, I actually, this is the official diagram from the Docker, so I take it from there itself. So this is the, if you see this down, this is the, you can say, logo of Docker. Okay, and here you can see a big whale is having lot of containers, or you can say big ship is having lot of containers. Okay, so this is my daemon. So this indicates that there is a service running in my operating system. Okay, on top of that, we are having a REST API. So you cannot directly send the message to Docker daemon. It is through REST API. Okay, so REST API, you know that it follows a pattern, design pattern, right? So to talk to the API objects. Now there are a lot of other things which we are doing. So say an example, we are managing the network, we are managing the containers, we are managing the images, Docker volumes, and other things. So the command which comes, it comes through the Docker CLI. Docker CLI, you can think it's a client, means you are writing some command. So that command is basically Docker CLI command. So the command comes to through the Docker client. Once that command comes, it basically sends to the REST API. And REST API prepares the instruction what a Docker daemon has to do. For example, you are saying, I want to create a network. I want to create a container. I want to create a volume. I want to remove a volume. I need to remove a container, and so on. So it could be any task which is related to the Docker. So that task is performed by the Docker CLI. When it runs that command, it goes to the REST API. REST API creates the set of instructions which is to be performed by the Docker daemon, and it gives that instructions to the Docker daemon. Docker daemon performs that task, gives back to the REST API. REST API gives back the response to the Docker CLI. So this is how Docker engine works. So now let us discuss about this. So as I mentioned that we will talk about Docker registry, or sometimes we call it Docker repository. So the question which basically very frequently asked question, that where are these images? Who develops these images? Where we can get the from where we can get the basic images? Do we need to create our own Ubuntu image without kernel, or we have something which is ready-made available? Yes, it is already available. These images are available on Docker Hub. What is Docker Hub? Docker Hub is collection. This is the official um, repository from the Docker. So Docker has lot of images on its Docker repository. Okay, so if you want to create a custom image, but for that custom image you need a base image, and that base image you can download it from the Docker Hub. So Docker Hub is the collection of images, and we download that image we download that image from the Docker Hub. And these are publicly available. Some of the images are publicly available. Most of the images which is you know most of the images which is very frequently used, these images are publicly free. But you you will find some of the images which is not publicly available. Say an example, you create one image and you upload it to the Docker, and you are uploading it to the Docker Hub. You don't want to make this image publicly available. You want to make it as uh, private. You can do that. So it means that image will not be accessible to everyone. It will be accessible to you. Okay. If you create a lot of private images, you need to pay to the Docker Hub. Okay. But publicly available images are free. You can create the account in Docker Hub, but to download the image for which is publicly available, you don't need that. You need not to have an account on Docker Hub. Okay. So in this diagram, let us understand this diagram. In this diagram, we are having um, Docker client, we are having Docker host, and we are having the registry. So registry as of now, you can consider that uh, it is collection of images. Okay, it is the collection of images. So we will talk in detail about the registry in the registry lecture, where we you can create your own registry. You can uh, you can use Docker Hub. So either of this way you can do it. We can create our own registry, which is called the Docker registry. Okay, so say an example, you don't have the internet connection and you want to connect, you want similar kind of functionality as Docker Hub is providing, but it should be on your organization level. Then you can create the Docker registry. Fine. Now, here you can see there is a client. Okay, and this client is the client who sends the request to the Docker host. So Docker host is the machine where your Docker is where your Docker daemon is running. Okay, yeah. So here your Docker daemons means it's your server. It's your server where the Docker processes are running. Means you want to you want to pull the image, you want to create the containers and so on. Okay, so Docker client is the one who is requesting for or who is running the commands. Okay, so that is the Docker client, and Docker host where the Docker daemon is running, and registry is where the collection of images are available. It could be your Docker hub, it could be your Docker registry, right? As I mentioned that on organization level you can create your own Docker registry. So client is sending a command. So these are some commands like docker pull, docker build, docker run. Don't worry about that because you don't know these commands. I know if you are totally beginners to Docker, if you are aware of these commands, then it means these commands we are running. Okay, we will be discussing these commands in details when we are dig into this topic. Okay, so Docker client is writing some command and sending it to the Docker host, and their Docker daemon is running. Docker daemon is saying, yes, what can I do for you? And it is saying, please create a container. Docker run command is saying, please create a container. And Docker daemon is saying, okay, I'm at your service. Let me do that. And it is not like that anyone can request to the Docker daemon. Means that the client is an authorized client, right? So this Docker daemon takes that request and it checks what I need to do, what this command is saying. Docker daemon is saying, okay, what can I do for you? And Docker run is saying, create a container. For creating a container, I need an image. And do I have that image on my Docker server? No, I don't have. Let me get it from the Docker registry. If it is already available on your local system or your Docker host, then it won't go to the Docker registry and download it because it is already downloaded. But if it is not on the system, then it approach to the Docker registry, download that image, create the container, and send back the result back to the client by saying that, okay, sir, we have created a container for you. Client is happy. Daemon has done its job. Daemon is happy. We are happy, right? Because we are writing some commands and these commands are successfully getting executed. So we are happy too. Okay. So overall, this is how the flow of Docker happens. Okay. So now let me go to my let me go to my this is disconnected. Let me reconnect it. Okay. So I'm on my Ubuntu system. So I have Ubuntu system. Let me clear the screen. If you don't know how to do that, you can write clear. You can press Control L to clear the screen. Okay, either way. So what we are going to do, we have a separate session how to install Docker. But because this is a totally new machine for me, I need to install Docker. And it is very quick for me. For you also, let me change this host name. This is a EC2 instance of AWS. So you can take any machine which has Ubuntu system installed on top of that. Okay, so no need to worry. Means whether I need to take a uh, uh, I need to take a virtual box, I need to take a VMware, I need to create an account. I need one operating system with one virtual machine. You can do it on the physical system also, but I would prefer to go with the virtual machines. So here, what I'm going to do, I don't like this is the host name, right? This is the host name, this is the username, and this dollar. This is not US dollar. This is Linux dollar. Okay, so this indicates that I am not logged in with the root user. Okay, so let me log in with the root user because otherwise I may have certain um, I may have certain restrictions, so which I don't want. So I want to log in with the root user sudo su. So now you can see this is changed with the hash symbol. Earlier it was dollar symbol, which indicates that you are connected with the root user. Okay, now you are root, you are administrator. You can do anything. Don't destroy the environment. Okay, don't take the advantage if you are a root user. Help others, right? So you are going to help others. That is why you are an administrator. Don't spoil the things. If you don't know, don't do the things because you are a root. All right, so here you can see earlier it was Ubuntu, now it is root. This indicates I am logged in with the root user. At the rate, and this is what? This is what? This is what? Anybody knows? Yes, you're right. This is the host name. I don't like this host name. Let me change this host name to, I'll say host name, and I'll change this host name to say Docker. Docker, spelling is wrong. Docker. Docker, Docker virtual machine. Oh, no, Docker machine. Uh, Docker 01. That looks good. Oh, it did not change the name. Why? Because I did not use the bash command. I need to restart the my shell. I did not restart the shell. That is why it is not appearing here. If you want to make it permanent, change your host name so that next time when you restart your system, it should be Docker 01. For that case, what you can do, you can go to that C and host name file, and this is the host name, and I'm changing it to the Docker 01. Save. Now you need to run the bash command, and we are happy to see that there is Docker 01. And don't worry, so far we have not discussed about the Docker. We are talking about the Linux commands only, right? You should be aware of some basic Linux commands if you are starting the Docker. So our course is basically uh, is more on the Linux base, even though we are going to discuss about the Windows level also. But major part of the course is related to Linux. Okay. So now we have changed the host name. This is Ubuntu, which has the apt repository, and I'm running a command apt update. So it will update the apt repository. And all the packages are up to date now. Now it's very easy to install Docker on Ubuntu. If I say apt install docker.io-y, so I'm basically installing the Docker. Okay, so it get installed. Now, once the Docker is installed, how can you verify it? Okay, so let us say Docker version. So when you run this command, you can see it has client version as well as the server version. And we have installed 19.0.3.6 client version and same version for the server. So it means on my system, it has both the version installed, means both client and server both get installed. So which is good. So we can run a command from here. That's why I was able to run this docker version command. Okay, because the client version is installed on it. Okay, so now let us see where is the docker. So if I say docker and so we will run a command. What is, as I mentioned, docker is a daemon. So where is that daemon? So systemctl status docker. So this is my docker daemon. Okay, so docker dot service, docker application container engine. Okay, and it's loaded and it is active and running. Okay, so it is active and running means my docker service is up and running. If it is not in the running state, what you need to do, so you need to check this systemctl status command. Okay, uh, if it is not in the running state, then you need to run this command. Let me press q to come out, and if I say systemctl start docker, so you need to run this command. In my case it is already started, so I'm not going to start it again. Okay. But probably uh, when you are installing it on Ubuntu, not Ubuntu, CentOS system, it does not start automatically. So you need to start manually with this systemctl start docker command. Okay, I'm enabling as well. So if I say enable docker, so basically, so a system link. So next time when I start it, my system, restart my system, this will be in the running state. All right. So now this Docker is installed, and we have seen that it is it is running as a service, which is a Docker daemon. So ultimately, all the tasks are performed by Docker. Um, these all the tasks are performed by the Docker daemon. Guys, if you like this video, if you like my lecture, this will be a motivation for me if you like it and subscribe it. So please go ahead and like it. All right. So now let us talk about Docker images. How can you see Docker images? You can run a command Docker images. This tells that there is no image. The new way to write the Docker images command, you can say Docker image ls. So both will return the same result. So these two commands doing the same thing. You may be thinking, why two commands? Why we get confused with two commands? We should have only one command. Yes, there was only one command, but now there is a categorization on the objects level. So, as an example, Docker images. Earlier we were using Docker images, and it is not going to decommission. That's for sure. Okay, so you can use Docker images, or if you think that Docker image command should start with the Docker image, Docker container command should start with the Docker container, you can write Docker image ls, Docker container ls, like that. Okay. Now, what I am doing with this Docker images command. So this command is basically downloading the images. Not downloading. This displays the images which is downloaded on your system. So far there is no Docker image. Now, if I run this command, Docker pull, say an example, CentOS. Now, what this command does, this command pull the image from the Docker Hub. As I mentioned, that Docker Hub is nothing, but it is collection of Docker images. So let me just quickly go to the Docker Hub. Okay, let me do it this way. If I go to Chrome and if I say hub.docker.com. Okay, so this is the official website for Docker Hub. Okay, I'm not going to sign it up. I'm just searching for an image. So if I say CentOS, okay, so here you can see it is an official image. Okay, if it says official image means it is created by Docker. It's created by Docker means it's not created by some user. Okay, 10 million plus download. Oh my god. Okay, 6.1k stars. So let us see what it contains. What it is saying, this is the proper documentation. Why it is a proper documentation? Because it's a Docker official image. So they create the proper documentation. There are some links which you can directly go and you can learn more about these images. So you can download CentOS 7, you can download CentOS 6, you can download, you know, other images. Okay. This is the description about that image. Okay. And here you can see some more documentation about that. So you can go through that image This is the Docker file, which will be little advanced. We will talk later about this, not today's lecture, definitely. So, but what here it is saying, copy and paste to pull this image. So I'm copying, you can click on this, and it is saying Docker pull CentOS, and that's what I have written here, right? Or you can copy paste here. So when I run this command, so I have not mentioned any tag. So it means, so it means it is it is downloaded. It is downloading the latest image. Okay, so if you don't mention any tag, so what I mean tag, if I say Docker images now, so you can see there is a new image, Docker image, which is latest. This is the unique ID for each image. 43 uh, 43, not years, definitely not years, hours. 43 hours ago it was created, and the size, so this is only 215 MB. You might be surprised. Your eyes might be widened. Reason? Because it is only 215 MB. Okay. So now if you go back to your server, and here you can see you can download 7, 6, 7.8, 7.4, 6.10, different versions. So these are the versions of the image available. So if I here, if I say Docker, and if I say pull CentOS colon 7. So it means I want to download, or I want to pull the image, which is a different image, the one which I have downloaded earlier or pulled earlier. It is different from that because now the tag name is different. So if I say Docker image ls, so you can see it is 7 tag, means this is CentOS 7. And if you know more about that, you just click on this, and it's a hyperlink. It will redirect to that page where it is talking more about the CentOS 7. Well done, fantastic. So we have downloaded an image. Can we download Ubuntu image? First we need to see whether Ubuntu image is available on the Docker Hub or not. Yes, it is available. Again, 10 million plus download, 10K plus stars. Wonderful. All right, so here you can copy this command to pull the Ubuntu image, paste it here, and run it. So it will take the latest version because I have not mentioned any tag. It is pulling the image, and image get downloaded. Okay, so in our lecture we will talk more in detail about the Docker images. So it is just an introduction, right, where we are talking about images. But but in our course, we are going to deep dive into the Docker images, where we are talking about the file system. We are talking about the isolation level of the Docker images and Docker processes. Okay, and now if I say uh, Docker images, so you can see we have Ubuntu image as well. Running Docker images is called containers. Okay, so okay, so running Docker images is called container. Let's run an image. How to run the image? You need to run a command Docker run minus it. Minus it is interactive terminal, and hyphen hyphen name, which is optional. You can give the name of the container. So I'm creating one container, and container name I can give it as web server. Okay, and minus d is the detach mode, means I want to run this image in a background process. So minus d, and the image name. So I'm using CentOS image. Now what it returns? It returns a container ID. So if I say Docker container ls, so it will show that this is the container ID. This this is the short form of, this is the big form of the container ID. This is the short form. This image it is using. This is the command. 10 seconds ago we have created it. It is up and running. We are not using any port forwarding. That maybe we are discussing in some other lecture. And the name of the container is web server. Can I go inside this container? Yeah, absolutely. You can go inside the container. Going inside the container is similar to go to go inside a virtual machine, right? So if you are thinking, if you are comparing with the virtual machine, then you can consider that going inside the container is basically going inside the virtual machine. So let me run a command docker execute -it, again interactive terminal. You can use container ID, you can use container name, either of this. I'm using container name, and bash. So this shell I'm going to use. Now I'm inside the container. See, prompt get changed. This is the container ID, root at the rate container ID. So we are connected with the root. You can connect with the user also if you want, but here I am connected with a root user. Okay, so that's a, again it's a separate topic, how to connect with a particular user. But now from the starting level you need to just think that you are connected with a root user. Now here if I say ls, so you can see there is no, actually I don't know whether you have noticed or not, I'm running CentOS on top of Ubuntu system, and this CentOS is my Docker image. Now it is running as a container and it does not have any kernel. So where is the kernel? Kernel is the, absolutely, it's a host operating system's kernel it is going to use. And this file system, ultimately it is getting stored on your host operating system, but there is a file system. So when I run inside the container, I can do anything. I can make a directory and I'll say make a directory test. And if I say ls, so you can see there is a test directory get created. So I believe now you have a fair understanding about container, images, how to go inside the container. Let me come out of this container. Can I power off this container? Can I stop this? You can stop it. Docker stop and the container ID or container name. I'm using web server, so I'm stopping the container. So if I say docker ps command, so docker ps command is also list out the containers. But here I cannot see the container which I have stopped because docker ps command prints the containers which is prints the containers which is in the started mode. So this is not in the starting mode. This is in the stop mode. So how can I see that? To see that you need to say docker ps minus a. Minus a indicates all. Okay. So if I say docker ps minus a, and here you can see this is exited 0 is the basically the error code. 0 means it is normal shutdown, and 43 seconds ago it was stopped. Okay. So okay. So all right. So 43 seconds ago it was stopped, and name of the server, everything is fine. So can I start it again? Yes, we can do it. So you need to run a command docker start. Okay, so when you run this command docker start web server, so it is basically going to start the server. So now let me see docker ps, so I can see this particular server is in the started mode. Okay, so here you can see that this particular server which I have stopped, or server or the container you can say. So uh, now this is in the started mode. Now you can again go inside it and you can, perform the operations. So you can start, you can stop, you can pause, you can kill. Okay, so let us talk about kill. So killing a container, basically you are stopping a container. But stopping a container is something not in a normal fashion. That is called Docker kill. So say an example, your container is uh, once your container is basically once your container is in the abnormal mode or not in responding mode and you want to stop it, you can run a command docker kill and the server and your container name web server. Now it is stopped. If I say docker ps minus a, so you can see that it is exited, but earlier it was zero code, right? Now it is 137. It means it is uh, not it is not the zero code because it's not a normal uh, it's not a normal shutdown. It is a forcefully shut down. Okay, so that is why it is in the 137 code. So there are some exit codes for the containers. So we will discuss in some other lecture. But 130, if it is not zero, it means it is not stopped in a normal fashion. So if I want to start it, you can say docker start web server. Okay, now if I say docker ps, now again it is in the started mode and 4-second echo it was started. Okay, so I think now are you are familiar with what is Docker, what is Docker images, and also you are having some basic knowledge of Docker container. But there are a lot of things ahead which we can discuss about this Docker images and containers. This is a kind of a introductory level of definitions for the Docker images, architecture, and the Docker containers. Thank you very much for watching, and please do not forget to like and subscribe it. I'm telling again and again, this will definitely motivate us to create some good videos for you which will be knowledgeable. So please don't forget to like and subscribe. Thank you and see